All right. Hey, everyone. Welcome to the 28th Core Dev call. Today, we'll have a pretty good or interesting agenda, different stuff. But first and foremost, if you're new here, as always, these Core Dev calls are recorded. We have it on a monthly basis. The goal is to share major updates with you folks and hear your feedback on those things. Everything is out in the open, so I highly recommend you to check out our forum. There's a section where the different core dev teams are sharing updates on a monthly basis. I think those are super useful. And if you want to subscribe to future calls, make sure you follow our ecosystem calendar. You'll find it at the graph.foundation. And yeah, you can join these calls, you can talk, you can ask questions, you can participate. So today's agenda, oh, wait a minute. Yes, this is the right one. We'll have Pablo joining us, talking about some GIPs that have been recently deployed and approved. Then I'll be the first. I'll start with the CIP, the chain integration process. I'll quickly go over it. I don't want to spend too much time on it, but some folks have been asking some questions, so hopefully this call will clarify a few things. And then we'll have Adam focus on graph node. There's interesting upcoming and experimental features we can showcase and talk about a little bit. And then last minute addition to the agenda, Matthew from Pinax. They've been working on a solution to store and save the blobs, as we say, related to the EIP-4844. So very cool. Let's get started with the CIP, what it is. Let's see. So this is pretty much the follow-up to the old MIPS program, if you know what it was. It's called CIP, it just stands for Chain Integration Process, and it's an attempt at facilitating the onboard of new chains to the Graphs network, basically, while ensuring good quality of service on those chains. It is a foundation-led initiative where we help ensuring new chains, that the new chains can get the best-in-class decentralized subgraph indexing service. And this means we can work closely with those applying chains and work closely with our network of indexers, preparing them, and then the council who is currently ratifying full protocol support for these chains. And so, and I have some KPIs on the slide so you can see how the network is currently performing. And yeah, it is a simple but involving process as we aim to make it simpler over time. So I'll quickly go through how it works or how chains can apply and go through this process really. I'll start. So the first step really is to go onto our forums. We have a category in there where you can create a new thread. There's a template where we ask you we just ask you a few questions, and that is the official way of getting started really. I'll show you where the forum, I'll show you a screenshot of the forum where we have this. Then once chains apply, we move on to testing, and this is easy. If you're an EVM chain, the graph node integration should work right out of the box. If not, the preferred integration scheme right now is by developing what we call the firehose. So there's a firehose for each chain, which GraphNode already knows how to talk to with that particular component. We do have documentation online that'll help you get started building this firehose component for your chain. And if you need help, you can always reach out to core development teams like Streaming Fast. That was the team behind that tech, and they can help you build it as well. So assuming the GraphNode integration exists, we then work with indexers from InfraDAO. They act as the QA team, and they are the set of indexers who do some performance and reliability tests, let's say, on the whole stack. So we test different clients, our underlying blockchain nodes, I mean, if applicable, of course. Not all chains have client diversity. We look for data determinism issues when doing subgraph syncing. And we also create guides that featured indexes will then use to operate that new stack once available on our network. At the same time, on the subgraph developer side of things, we work on the studio. So that is Subgraph Studio. And that is the GUI that that's the current solution we have to ensure that developers can publish subgraphs to the network, do things like handle versioning, curation signal, which is the current mechanism to attract indexers to serve that subgraph. And yeah, so the foundation, we handle most of these things. We work with the council, the indexers, Edge node on the subgraph studio, just to ensure that the experience is there and the quality of service is there. And lastly, assuming there are no issues with all of these, we move on to getting full protocol support, and that is through a governance vote. So the council votes on this proposal the foundation puts together. And once that proposal is passed, then developers and consumers can make use of our network, and indexers get indexing rewards for serving such subgraphs. So there's the protocol incentive there. And again, this may seem like a lot, but we do help you along the way. And yeah, once we have the graph node integration going and working, 80 and 90% of the work will be on us and indexers to get this thing available on the network. So that'll be that's the process. Lastly, yeah, just a quick screenshot here where you can see where you should click. Like if you want to create the forum thread, this is the section you should go to. And then you'll be presented with a template that you can fill, and that effectively gets you through the process. We are currently working with InfraDAO on supporting new chains. Some of them are going through the process. Some of them are already available on the hosted service, and we want to get more indexers to support it, other than the upgrade indexer recently announced. So that means Starknet, Astar, zkVM, Base, Binance Smart Chain or BNB Chain, Scroll, Linea, and Bitcoin being the new addition. Yeah, that's pretty much it. Let me look at the chat, see if there's questions. This is obviously more tailored for blockchains that wants to apply and get full protocol support. Okay, I see, Paulo, you need help with allowing co-hosts. Okay, I'll do that. And yeah, I don't see questions in the chat, so I should just move on. Let me make sure that Paulo can talk. Not Paulo, sorry, Pablo. There you go. Pablo, you should be able now to talk and present.
Hello. Yes. All right. Yeah. Thanks for having me. It's always great to be here. I'm going to quickly share screen. It's a quick update just about these GGPs. So these are the graph governance proposals. That is the way in which the council votes for GIPs, the graph improvement proposals, and kind of formally approves their deployment. So there were 3 GGPs that had been approved a while ago. These are GGP 31, 34, and 35, and they relate to 4 different proposals because one of them had 2 of them in the same vote, just for convenience. And these were approved a while ago, and we've recently actually deployed these to Arbitrum 1. So they are now part of the protocol, and these improvements are now available to anyone using the protocol on Arbitrum 1. They've only been deployed on L2 and not on Ethereum Mainnet because, as most of you might know, the indexing rewards on L1 are slowly going down towards 0%, and they're currently at only 5%. So like the decision recently has been that new upgrades and improvements like this will go to Arbitrum 1 only. So GGP 31 includes 2 GIPs, and that is one is storing the dispute status and dispute resolution, and this is an upgrade to the dispute manager contract. That is the contract that handles arbitration disputes. And so far, the resolution of those disputes wasn't stored on chain. And this was a proposal that was done by the Soulbound Labs team because they were thinking of using that dispute status to do a sort of subgraph bridge. I'm not sure if they're still working on that project. So this GIP wasn't kind of prioritized over time, but it was tested and audited and so on for a while. And finally, we included it into this deployment. So it's simply a dispute manager upgrade, and it basically means that if anyone wants to use the status of disputes and check if a POI, for instance, has been disputed or not, to do some form of optimistic, I don't know, optimistic part proof based on that or something like that, then they can do that now. And together with that, we deployed removing the owner tax on subgraph upgrades. This will hopefully be quite an improvement for subgraph developers. When you're publishing the new version for a subgraph to the network, up to this point, you had to add a few GRT to pay for a bigger portion of the curation tax. There is a curation tax every time new subgraph deployment is curated. There's a percentage of that is burned. And up to this point, subgraph owners had to pay a larger percentage of that than the other curators in a subgraph. And we have now removed that based on the approval of that proposal. And that means that now, whenever a subgraph is upgraded, all of the curators will pay the corresponding fraction of the curation tax without the subgraph owner having to add additional GRT at the time of doing the upgrade. And so hopefully that simplifies the experience. And then the other GGP that is enabling permissionless payers is removing a restriction that we had in the staking contract by which only specific addresses were able to inject fees into the protocol. And these specific addresses are generally related to gateways. So if a gateway wants to pay fees into the protocol and into the rebate formula and all of the protocol fees and so on, previously they had to be allow listed by the council, and now that is fully permissionless. So this is another step towards further decentralizing the graph. So yeah, it's pretty cool that we were able to get that out. And that means that now anyone can inject fees into the network. Obviously, there are other things involved in setting up a gateway, but at least there are no restrictions at the protocol level at this point. And then finally, GGP-35 that has to do with GIP-62 is about removing delegation parameters cooldown. That is all indexers, they can set their delegation parameters, that is how much of indexing rewards and how much of the query fees are kept by the indexer versus distributed to their delegators. And there used to be this cooldown period where the indexer could sort of block themselves from doing changes in a certain period of time. This wasn't really used, at least hadn't been used for a couple of years. And it hadn't been used on Arbitrum 1, actually, except for a single indexer that had set it, and due to a UI bug, they got it set to a different value than they expected that was much longer. So this change removes something that wasn't used in the protocol. It's always nice to simplify the contracts. And also it allows this indexer that had this problem to now be able to change their delegation parameters as needed. And this cooldown was meant as a way for indexers to provide more confidence to delegators that they wouldn't change parameters right before collecting rewards or something like that. But in practice, there's already this relationship where delegators choose their indexers. And if an indexer were to kind of play with this in a malicious way or in a way that affects delegators, delegators would simply move to other indexers. So it wouldn't really be necessary to have this cooldown, or it wouldn't. It seemed that it didn't really add much value to the protocol. So yeah, these are the 4 changes in these 3 votes that were now deployed. So hopefully, yeah, to keep improving the network for everybody. So yeah, that's it. Thank you.
Right, thanks, Pablo. Looking at the chat, no questions. I also don't have follow-up questions, so we should just continue. Thanks again, Pablo, for always being available to join this call and provide updates. Super appreciate it. Next, we have Adam. Adam, can you talk?
Yeah, how's it going, everybody?
Good, good, good.
Cool. Shall I go? Let me share my screen. Cool. Can you see that?
Yep.
Yes.
So just a quick run through today of some graph node changes. I checked, and I think last time we did a sort of batch like this was yeah, I think maybe in October. We've had a couple of releases since then, so I want to talk through some of that functionality, and then also talk about some of the things that are in the lab at the moment and should be hopefully rolling out soon. Yeah, so there've been a couple of releases, as I said. So release 33 at the back end of last year. This featured a bunch of the stuff that we talked about last time. So everything from file, RWE file data sources and polling, sort of infrequent block handlers, through to data source context. So being able to provide more information in the manifest, which can then be accessible in mappings, as well as support for pure substreams chains. So obviously one of the big things we did last year was add support for substreams in various ways into graph node, and so that's something which continues this this year. But this essentially allowed you to run a chain without having to have a RPC. So it essentially opened up a bunch of chains which couldn't be supported before. And then 34.1, so there's a small patch release to fix some bugs here. So there's some more substreams triggers. So substreams triggers essentially, so previously the graph node integration was dependent on a very specific interface between substreams and graph node. So essentially on substreams which output graph entities, so essentially just entity changes. This essentially is a bit allows for a bit more flexibility in that integration, and that you can take the output of any map module and then process it in subgraph handlers. So that theoretically means that even if there's a substream package that you wanted to extract some data from, but it wasn't quite exactly what you needed, or if it didn't have an entity output module, you could still grab that substreams package and grab the map module that you're interested in, and then process that in your subgraph. So it's still pretty experimental. It does have a lot of potential in that this could be a nice and pretty seamless way to integrate new chains, and that's something that we're experimenting with, but also like still sort of kicking the tires and making sure that this works as expected, particularly at scale. So then another thing, so indexer hints. This is quite a long-awaited thing around pruning. So pruning was a feature that was released last year where indexers could prune essentially archival data from their subgraphs, which would essentially potentially make the data much smaller on disk, and also speed up queries. And so has a lot of benefits. One of the challenges was how subgraph developers could kind of indicate that they're okay with removing that archival data. So now they can provide those hints in the manifest, so indexers can essentially see that subgraph developers like happy for data to be pruned. Obviously, they're only hints. Indexers can choose not to prune, because it may be that some data consumers want that archival data, others don't. But in general, we're seeing moving to pruning as sort of best practice, and trying to have less reliance on time travel queries. mblock was another one. So this has been a long-standing feature request, which essentially lets you say that you're no longer interested in listening to a data source after a certain block number, and then another smaller one was auto-generating IDs. So essentially just an incrementing ID. So just a small quality of life thing. And then I think the last one I'm going to spend a little bit more time on was initial StarkNet support. So this is cool on a couple of levels, in that it's been done by a member of the StarkNet sort of community. So they wanted subgraphs. StarkNet is not an EVM supported supported chain, and so this was done by a member of the StarkNet community who built a firehose, as I think Pedro mentioned in the last section. So that's sort of the baseline thing that's required for integration. And they also created a native graph node integration. Whereas and so this has been rolled out in this release. I think this is still being tested by InfraDAO and others on the network while we essentially make sure that everything works. I know that the person who the contributor is using this in production. They're using this to power their subgraphs in the front application, but this has not yet been rolled out on the network. But still, really cool to see this kind of open source contribution. So those are a couple of the most recent releases. In terms of things in the lab, aggregation, so declarative time-based calculations, this has been a feature which has been tailor-made for sort of known DEX use cases. So essentially time series, if you want to have a daily, hourly aggregations. Currently, you have to do quite a lot of manual calculations in your mappings. We're familiar with many subgraphs which do quite onerous calculations, and we want to make that simpler, less error prone, and also more performant on the subgraph indexing side. So it's been a big undertaking that's been led by David Lotter at Edgenode, and it's in the final stages now. I'm sure there'll be lots of folks who are interested in trying this out. We're interested in chatting to teams who could see use for this in their subgraphs, hopefully make their subgraphs slimmer and faster. Just to give folks a sense, this allows you to essentially identify entities where you want to create a time series. So these would just be the entities you save. So rather than calculating hourly rolling totals, you just essentially just save entities, and then you declaratively in the schema say, okay, I'd like to have an aggregation over the block entity. I'd like that to be hourly and daily, and then essentially a bunch of calculations that you can do on top of those things, and essentially GraphNode will take care of a bunch of the calculations in the database, and that'll happen sort of seamlessly. So as said, this is a bit of a call to folks who are interested. We're going to be hopefully rolling this out soon, and we'll be looking for beta testers of this new functionality. EtherGet balance, small one, but quite a neat one. This is another long requested feature, essentially the ability to fetch token balances or other native token balances rather than just to make contract calls. So this does unlock some use cases in terms of keeping track of token, like how many the balance of a smart contract, essentially any address. So this should also hopefully go out in the next release. And then quite a few other things. So everything from some dependency upgrades, which were kind of long awaited, some small things to improve essentially tracking reorgs for folks who are particularly sensitive to those kind of things, filtering based on index arguments. We've got some experiments happening around like parallel trigger fetching, pre-filtered subgraphs, and then a couple of other redacted sort of special projects, which we're pretty excited about. So there's quite a lot cooking as well as as I said, the aggregations features a big one for us. It's been a long time coming. So I think that's the main update for GraphNode. Not sure where we're at on time, but that's all I had, Pedro. Questions, welcome, if anyone has any.
Thanks, Adam, for presenting all of that. Yeah, aggregations, Matthew is saying, looking forward to see what people do with. Agree. I'm not sure. I'm sure Derek from, at least from Builders DAO, maybe he will want to do something there as well, experiment with it. I don't see questions. I don't see comments. So we should move on. Or before we do, maybe Adam, how you said you would have some beta testers. What is that? How are you thinking of reaching out to folks to test it?
Yes, there are a couple of people we're in touch with already, but yeah, we'll also certainly be I think Derek, who is here, would be on the list of folks we reach out to once we've got something that's end-to-end usable. But And yeah, we'll probably also be reaching out via the builders newsletter, which goes out every month. Sign up for that if you don't already. So yeah, we're in touch with some people, but definitely a call for others too.
Interesting. I was trying to see if we had Nasari on the call, but we don't. All right, cool. Let's move on. Matthew, Pinax, show us what you got. Blobs. We all want to see blobs. Matthew, you talking? You're muted.
Yeah,
There
there
you
we go. Can you see my screen?
Yeah, and hear you.
All right, beauty. All right, so yeah, I'm going to talk about a little bit about blobs, so or EIP-4844 support. All right, so what is that anyway? So I'm going to go into all the details of what that is, but in short, it's a way to store blobs. And it's a way to store blobs that does not bloat the main Ethereum execution layer or any other chain that decides to adopt EIP-4844. Because, you know, like your Ethereum client, you might want to still run it on a Raspberry Pi, and if we store a lot of blobs, well, you know, your Raspberry Pi would run out of storage. So storage blobs are handled by the consensus layer and not the main Ethereum execution layer. So what is a blob and what it's going to be used for? Well, you know, it's just a bunch of data and people can decide to put whatever they want in there. So we know it's going to be used for rollups. Somebody suggested that when I was talking to them earlier, maybe inscriptions, you know, who knows? There's lots of ideas out there. I'm not going to list them all here. And there's probably lots of ideas that have not been invented yet of, you know, what people are going to do with this. So Ethereum, we're going to, you know, be able to process more data on chain by having blobs, but the blob's only stored for 18 days. So what if you want a blob from, you know, 2 years ago? Well, yeah, let's discuss that. So long-term blob storage. So consensus layers by default are only going to store 18 days, but you know, you can change that configuration and make them store blobs forever. So, okay, that's good if we want to keep them. Various RPC providers have announced that they will be storing blobs, so that's good. But what about the graph? So we have a firehose implementation, so that can store blobs in flat files, which is really cool. So I'm going to talk about mostly that implementation today. But you know, as I mentioned earlier, a lot of the use cases for blobs are unclear, and so depending what we see evolve in the ecosystem over the coming years, days, months, years, we'll see, you know, what we want to do about storing, processing, doing things with blobs. So stay tuned. So the Pinax team has built, we'll call it the beta in quotes, firehose beacon chain. So this is going to read all the blocks or slots coming from a beacon chain and store those into the normal kind of firehose flat files, just like we would do for, say, Starknet or any other Ethereum chain, or, you know, Cosmos, or, you know, any other chains that we support. This is just yet another chain. It's using the streaming fast RPC polar. You may have remember from previous sessions that the streaming fast team came up with the RPC polar in order to quickly onboard new blockchains with the firehose tech. So we're using that here, and the source code is here, and so is the protobuf. So if you want to start looking at what we built, we have some links, and we built some substreams to use the firehose as well. And I'm going to show you a quick demo of one in a couple of slides. Which also needs the subtivity substream sync, which is the last link on the page. So we can read the blocks using RPC polar. We can store them as firehose blocks. We can process it with substreams, and then whatever you normally do with substreams, you can do that once you have, you know, the firehose blocks. And the firehose blocks do contain the blobs. So what does that look like? Well, here's, you know, an output of a beacon chain or a consensus layer chain. So I don't know, it outputs things like gas limit, the timestamp, and, you know, the actual blobs. So the actual blobs there. You know, there might be more or less blobs in any one block, but you know, that's kind of the idea of the format that you would see. What does that blob mean? I have no idea. But somebody's storing something that is meaningful to them, and you can now retrieve it. So here's a quick example that we built just to show that the whole stack kind of works together. So we started with our beacon chain. So in our case, we're using Lighthouse, but any other consensus layer client should work. They all should have the same API. We only tested Lighthouse. We're using the streaming fast RPC polar technology. So we've built a firehose beacon implementation of that RPC polar, and it will generate the flat files. Then we're using substreams to extract the data. So we have a few substreams that we built. And then we're running the Prometheus subtivity sync. So we're taking the data from the substreams, we're making it available as a Prometheus exporter. If you're in DevOps land, you're probably familiar with Prometheus. So it looks the same as you would do for monitoring any of your infrastructure. And then we're storing the data in Prometheus and exposing it using Grafana. So this is just a quick way to do some testing to see whether the thing works. So here we can see the number of blobs, you know, per second that are being generated on the Goerli testnet. Cool. So where do we go from here? So we got a little example. It works. That's nice. But really, we need feedback. So if you're talking to people out in the world, you know, let us know what they're want to do with blobs, what they're using blobs for. You know, how can we help with blobs? So if you got feedback, please send it to me, Pedro, Adam. You know, any of us are interested in terms of what's going on with these kind of use cases. So that's number one most important thing. We want to know what people are trying to do with this stuff, because that will then inform the next steps that we take inside the graph in terms of where we go next. But short term, you know, this implementation is pretty recent. So we're still validating and adjusting the block model. So that's why I mentioned it's kind of in beta, because we might make a few changes here based on you know, initial feedback from a few community members. We want to see what information we can read from the chain. Is there anything we can get out of the blobs that might be interesting? Maybe a test case. And then, as Adam mentioned earlier, we have all the new support for allowing substreams to integrate easily into the graph node and populate data. So we just need to test that implementation and see if that works smoothly. So hopefully it does, but we should just test that. So this is the idea of kind of things that are, you know, kind of immediate next steps. But then what do we want to do with blobs later? I don't know. Do we want to store in the key value store? Do we want an RPC? Do we want to use file hosting service? I don't know what ideas people have for blobs. So based on feedback, then we'll adjust plans accordingly. We do have this running in Pinax infrastructure. So if you want to have access to this firehose and substreams implementation, feel free to send me a message and we can see about getting you set up for that. We're going to support Goerli, Polsky, and Sepolia, so the testnet. So the Dencun hard fork has been enabled on those chains. We're planning to add the firehose for the other chains as they go through that same hard fork. So Gnosis March 11th hard fork, and Ethereum is on March 13th. And I don't know when all the other chains are doing this. So there's a lot of activity around this EIP-4844. So stay tuned. We'll add other chains as well. That's it. My contact, you can contact me on Twitter or Discord, or find me around somewhere. That's it. Questions? Links back up there.
This is very cool, Matthew. I know it's been put together in a couple of days, and it's incredible what we could achieve. It goes to show what the the benefits of using the firehose RPC polar if we want to have subgraph support or substream support on any given chain or yeah.
Yeah, it's you know, it's super easy when you've got a blockchain that's got a well-documented API that makes sense. Then you know it's straightforward to integrate here. And the interesting thing is in beacon chain land, it skips over blocks. So the streaming fast, you know, the block numbers are not consecutive. So the streaming fast team did a whole bunch of work to make that work previously for, I think it was near. So that all, you know, the stuff that's all been built up till now made this implementation very easy.
Yeah. The other is saying, for perspective, chain can push up to 4 GB of data in blobs per day. Where are you seeing that usage? Is that
it's possible to.
It's a theoretical limit. Okay. Alexi, is a goal to have support from the L2 client nodes for archive sync support? I think that would be best suited for the RPC data service, as we mentioned, because they would need to get, yeah, they would build, assuming they would use the RPC, or they need to be compliant with the RPC API, let's say, when syncing. So I guess that would be more suitable for that particular data service. Right?
Yeah, I'm not sure I quite understood the question, but
Alexi, do you wanna? You can. Yeah, you can.
I thought the question was, yeah, was around basically persisting the blobs.
Yeah, I was just wondering if you know, how today we have Arbitrum, let's say Arbitrum archive nodes, right? To be able to index and such. And how will these archive nodes work when you know, after EIP-4844, since they won't be able to recover historical data from the blockchain anymore? Like, how would you sync an Arbitrum archive node basically after EIP-4844? I was thinking perhaps this blob solution could be proposed as a you know, a solution for EIP-4844 archival, like an official solution for that. Like,
yeah, I mean,
at the Ethereum Foundation or something.
potentially, I guess, could be done.
So we're already working on EIP-44.
4444. Yeah, exactly. So this
Yeah,
is
for an official support basically from the Ethereum Foundation. So that's similar.
So I think it's,
official.
I think it's so I think there's a slight nuance because these are blobs on the beacon chain, which are like with DL1, which are of interest to rollups, like of interest to rollups, but not sort of required for an Arbitrum archive node. I think those that that history will like essentially that's a sort of separate execution, but ultimately to have like challenges on the L1, you need access to the blobs. But yeah, I'm not sure in terms of the actual like window of time. But I think that, yeah, one area of exploration still today is like, we know that rollups will want to sort of keep the blobs around if they want to use, like move to using that approach for their sort of anchoring on L1. The unknown is like if they're going to be other unexpected use cases of this pattern.
Alexi, do you have anything to share from semiotic that you guys are you looking into EIP-4844? Anything relevant you want
Not
to
that
share?
I know of. Sevi would have been the most knowledgeable on this work track. But yeah, I don't think so. But I could imagine that being able to share verifiable blobs on the graph network could be useful, just to make it easier for well, I guess it would be even necessary, right? That'd be the only way for people to recover historical blob, would be to share it within ourselves.
Yeah.
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 Somebody's got to store it, but you can also like your blob will need to match the signature on chain. So presumably the blobs are verifiable
Easily, yeah.
easily anyway.
Yeah, true. We haven't looked deeply into how these blobs work, to be fair. So I know what they're for, but I don't know exactly how they're implemented.
Yeah, don't ask me the details either. Anyway, we've got a fire hose. It can store blobs. It can, you know, hog lots of flat file disk storage space. So,
And the beauty is that we'll have it on the network, and so we'll have redundancy, many indexers using it. So consumers who may want to use this GraphQL API in the short term can do so via our network and benefit from using the decentralized network. So as Matthew said, we need to figure out now what the other use cases are so we can optimize and ensure that we can serve those better as well. But for now, blobs will be saved, I guess. That's nice. All right, cool. We're done with the agenda, and I don't see messages in the chat. Is there anything you folks want to discuss? We have some time. All right. I'm not seeing any. And so let's just take some time back, which is always appreciated. Let's go back to work. And for those who will be joining Denver next week, feel free to stop by. We'll also have a booth. We'll be happy to talk to you. And if not, I'll see you in a month. Again, thanks for joining. Thanks, Adam. Thanks, Pablo. Thanks, Matthew. Thanks for taking your time and share those updates with everyone. Appreciate it. All right. Bye, all. Take care. See ya.